steel. First of which being that it's fast to erect. Here we can see a typical steel frame structure that has been erected much quicker and potentially cheaper than would have been possible with concrete. When building with reinforced concrete, you need to allow for formwork. This holds the wet concrete in place until it's strong enough to support its own weight. On the picture across, we can see the formwork that has been used during casting that could remain anywhere from 3 to 14 days. Bearing in mind, when these come off, it doesn't necessarily mean the structure can support any load besides its own weight, or even its own weight for that matter. This only means that it's not going to fall apart. Going back to our first picture, we can see here that this structure is ready to load as soon as the final bolts are tightened, a significant saving in time. Following on from the formwork, we move on to the temporary supports, or propping. Although used at the same time as the formwork, it's important to recognize that the temporary propping is more concerned with supporting the slab or column until it can take the loading currently on it at that time. In the case of slabs, a lot of the weight resisted is the slab's own self-weight. When a structure is filled with props, it's very difficult for the guys on site to get in to start finishing, and will often have to wait until the propping is removed. Whereas our steel frame is completely free of obstacles as soon as it's erected. Steel frame structures are also very light when compared to a reinforced concrete or masonry structure. This results in smaller and cheaper foundations. This is especially important when the founding conditions are physically unable to support a heavier structure. Lightweight might be the difference between a project going ahead or being canned altogether. Another time when this is an advantage is when adding an additional floor to an existing structure. Generally, only steel or timber would be light enough to be placed on an existing foundation. A typical steel column is also smaller than its concrete counterpart, meaning developers can sell more usable floor space. In larger cities such as London or New York, this floor space is very valuable, and you will be asked to get every millimeter out of a structure. It is also worth remembering that most countries class columns below a certain area not to be included in the lettable space sold. This may not seem like it will make much difference, but 40 columns over 40 levels very quickly adds up. Higher ductility allows steel a degree of movement before failure. This is particularly useful in earthquake zones, up to a point of course. And lastly, aesthetics. Steel can be used to create very slender, attractive structures, and this is why architects are very quick to go to steel when any of the support structure needs to be visible.